little champions. So your 10th board is approaching, and as you all know, we have started this 99% in 99 days course. So yes, today I am your chemistry teacher. Will be starting the chapter chemical reactions and equations. Okay, so students, this is very simple and easy chapter and a very high scoring chapter as well. Okay, so I'll be covering everything in this one particular lecture. So if you watch this complete video, then definitely all your concepts will be clear and all your examples will be cleared. Okay, so and one more thing, you need to join, like if you want the notes and all, so you can join our WhatsApp channel. The link of that is there in the description section. Okay, so yes students, ready to boost your preparation? Let's get started. So first of all, we'll be talking about like what are the things that we are going to study in this chapter. So whenever you study, just divide the chapter into sections and keep studying. Okay, that will help you to study better. So that is what I have divided here into 3 parts. So in the first part, we'll be studying about introduction, like what is a chemical reaction, what is chemical equation, okay, and something called as balanced chemical equation. Next, in the second lecture, so let us see first here, part 1, what are we going to study? Chemical reactions. Then we'll be studying chemical reaction characteristics. Okay, how will you know that a chemical reaction has happened? What are the observations that takes place here? Okay, next we'll be seeing one second, yeah, so first we'll be saying what is a chemical reactions, then its characteristics. Next we'll be checking chemical equations. What is the difference between chemical reaction and chemical equation? Fourth one, we'll be seeing about balancing a chemical equation. This is a very important topic from where you can easily expect the questions. Okay, so next, in the second part, that is types of chemical reactions, we will be discussing 5 types of chemical reaction. The first one is combination reaction, decomposition reaction, displacement reaction, double displacement reactions, and one more I'll add here. Okay, that is your oxidation and reduction reactions. Okay, oxidation and reduction reactions. Next, coming to the effects of oxidation and reduction, here we will be discussing 2 effects, that is corrosion and rusting. Okay, so yes students, now let's get started with the first thing, that is chemical reactions introduction. So what is a chemical reaction? Whenever 2 things, okay, react with each other to give you a new product, that is called chemical reaction. Okay, so for example, you have A, okay, reacting with B to give you something called as AB. Okay, and the properties of AB are completely different from A and B. So in that case, we call that a chemical reaction has taken place. Okay, and in this case, what is A and B? See, this A and B are called as reactants, means they are reacting with each other. This AB is called as products. Okay, clear? All are getting? Now, we'll take an example here, Mg plus O2 gives MgO. Here, which are the reactants? So what I can say, the magnesium has reacted with oxygen to give you magnesium oxide. Okay, so here magnesium and oxygen is your reactants. Okay, and MgO is the product. Clear? Got it? So next, coming to characteristics of a chemical reaction. So how can we know that exactly the reaction has taken place? There should be something to identify that. So chemical reaction, whenever it takes place, there are different changes that can be observed. Okay, some of them we have listed here. So first of all is a change in state. Suppose generally when you react solid substances, we can get gaseous products. Okay, some gas will be evolved. So that is a thing that you can see. Next is change in color. The color can change of the reactants. Suppose you are taking a blue color solution, reaction you added, and after some time some brown color it has taken place, right? Then also you can identify as the change in color can demonstrate a characteristic, or you can say that the chemical reaction has taken place. Next, evolution of gas, already explained. Next, we have change in temperature. Sometimes when you do the reaction and after the reaction is over, the temperature is either very cold or it has become hot. Okay, so that is also an indication of the chemical reaction taking place. Okay. So now coming to what is a chemical equation. Okay, the chapter name is chemical reaction and equation. So we understood what is chemical reaction. Now let us try to understand what is chemical equation. So now suppose magnesium and oxygen are reacting to give you magnesium oxide, right? So what I want to say that magnesium has reacted with oxygen to give you magnesium oxide. But do we have time to write these many big words every time? If there are more reactants, more products, can we write every time this much big words? So to simplify this or to shorten this, some tool we have, that is your chemical equation. Okay, so what is chemical equation? It is a symbolic way to represent the chemical reaction in the form of symbols and formulae. So what is the formula of magnesium? Mg. Okay, what is the formula of oxygen? O2, and then aromac. And what's the formula of magnesium oxide? MgO. Okay, so this is called chemical reaction, this is called chemical equation. Okay, I hope this concept is very clear to all of you. Okay, now we will go something which is very important, that is balanced chemical equation. Okay, so now you see this is chemical equation. A question may arise, ma'am, what is this balanced chemical equation? So I will understand that the number of atoms of each element is equal in the reactant and product side. So now if you see here, tell me what is the number of magnesium. Okay, we have magnesium here and oxygen here, right? So I'll make a table here. Okay, reactants and products. So what is the number of magnesium on the reactant side? We have 1, and on the product side also we have 1. Oxygen number of on the reactant side is 2, and the product side it is 1. Okay, so now you see the number of oxygen atoms on the reactant side and on the product side are not same, right? We have 2 oxygen on the reactant side and 1 oxygen on the product side. So these type of reactions are not balanced reactions. Okay, so this we can say that it is not balanced. Okay, not balanced. Then how can we balance that? So that is what we'll be seeing now. Okay, so let us take this example and understand how to balance a chemical reaction. So once again, this reaction, this is only H2O. Okay, so let me erase it. Okay, 1 second. Okay, so we have only H2 here. Okay, H2. So now let us do this balancing of reactions. So if you see, I have Fe. Okay, 1 second. Yeah, I have Fe here, I have hydrogen and I have oxygen, right? So if I give the number of reactants and the products, okay, so we have 1 Fe and 3 Fe on the product side, hydrogen this side 2 and this side also 2, oxygen this side 1 and this side it is 4, right? And we need to now balance it. So let us try to balance it. I'll write this reaction once again here. Fe, okay, plus water is giving me Fe3O4 plus H2. Okay, so now if you see, we have 3 Fe on this side and 1 Fe on this side, right? So what I can do, I can just simply multiply this 3 Fe here. So remember, to balance any chemical equation, you can multiply any number with the coefficients. Okay, so now you see it became 3 Fe, this also is become 3 Fe, right? Now if I see, oxygen here is 4 and here oxygen is only 1, right? So I can make this one 4. So that makes this 4 oxygen, it is balanced. But when I am making 4 oxygen, the number of hydrogens is now 8, right? So that is why here also I need to add 1 4 so that the number of hydrogens is 8. Now let us check the number of atoms. So we have Fe, we have hydrogen and we have oxygen. Okay, and if I see reactants and products, okay, so Fe here is 3 and here also 3, so yes, it is balanced. Hydrogen this side 8 and this side is also 8, yes, it is balanced. Oxygen this side 4 and this side 4, so this is also balanced. Okay, so I hope you have understood how to balance it. Let us try some questions here. So you have been given with one example here. So first let us calculate the number of atoms. Okay, so you have H, then you have N, okay, next you have oxygen, then you have calcium. I think these are the elements present. Okay, now if I write here reactants and here products. Okay, so now if you see hydrogen this side 1, okay, and this is OH twice, right? So that means 2 hydrogens are present here. So this side 1 and this side 2. So total I have 2 hydrogens on the, sorry, this side 1 and this side 2, total I have 3 hydrogens on the reactant side. And if you see product side, only here we have hydrogen, and that is 2 hydrogens. Okay, so let me give some space here. So we have hydrogen, nitrogen, oxygen and calcium. Okay, next if I see nitrogen, okay, nitrogen, how many atoms are present? Here only 1 nitrogen is present, but here I have, see, you can see NO3 twice is written, right? That means 2 NO3 groups are present. So in each NO3 there is 1 nitrogen, so total we have 2 nitrogens. Next if you see oxygen, so here we have 3 oxygen and here we have 2 oxygen, so I can say we have 5 oxygen. And this side if you see we have NO3 twice, so total 6 oxygen, and here we have 7 oxygens. Next calcium, if you see, yeah, this side also 1 calcium and this side also 1 calcium. Okay, so we need to balance this reaction. So let us start from the starting. So if you see we have calcium nitrate, we have 2 nitrate groups, right? So what if I write here 2NO3? Okay, let us check. If I write 2NO3, then what is the number of hydrogen we are having now? 2 hydrogen here and 2 hydrogen here. So total 4 hydrogen. And here we have only 2 hydrogen, so I'll multiply 1 more here, so I'll get 4 hydrogen. So hydrogen is balanced. Okay, now let us see what is the status. You have, okay, I'll change this one now. Okay, after adding, after giving these elements, is the reaction balanced or not? Okay. So I have, first is hydrogen, I have 2 hydrogen here and 2 hydrogen here, this side it is 4 hydrogen. And this side also I made it 2H2O, so I have here also 4 hydrogen. Nitrogen, I have 2 nitrogen here and 2 nitrogen here, yes. Next oxygen, if I see, here I have 6 oxygen and here, so we have total 8 oxygen here. And if you see here also 6 and 2, so here also we have 8 oxygen, and calcium we haven't disturbed. So yes, the reaction is now balanced. Okay, so we'll write the balanced reactions once again clearly here. So we have 2HNO3 plus CaOH whole 2 giving you CaNO3 whole 2 plus 2 water. Okay. Let us try the next question. Okay, so I'll erase this one. I hope you are enjoying, and you should also try to balance with me. Okay, so let us check the do the next one. So we have the elements here, sodium first. Okay, then we have oxygen, we have hydrogen, then we have sulfur, and again we have oxygen. So let us see how many sodium I have this side. On the reactant side I have only 1 sodium, right? And this side I have 2 sodium. Oxygen, here 1 and here 4. So 4 plus 1 I have 5 oxygen. And if I see here 4 plus 1, 5 oxygen. So oxygen is already balanced. Hydrogen, here 1, here 2. So I have 3 hydrogens. And if you see we have here oxygen, hydrogen, here we have only 2 hydrogens. Sulfur, here 1 and here also 1. Okay, that's what. Now let us try to balance it. So first of all, if I see this side 2 sodium, right? So this one also has to be 2 sodium. Okay. Now if I check this one, now let us see is the reaction now balanced. So after doing this one, I will check here what changes we can do now. So now if I see we have 2 sodium, okay, and this side also we have 2 sodium. Okay, oxygen, now if I see I have 4, 5, 6 oxygen, and here if I 6, 4 and 1, so I have 2 oxygen. So what I'll do, I'll multiply 1, 2 here. So if I now check, so here I have 4 oxygen and 2 oxygen, so total 6 oxygen, and here I have 4 and I multiplied, so now this also is 6 oxygen. Hydrogen, if I see we have 2 here and 2 here, so I have total 4 hydrogen here, and now this was also 4 hydrogen. Now if I see sulfate, so here 1 sulfur and here 1 sulfur, so 1 and 1. So yes, the reaction is balanced now. So 2NaOH plus H2SO4 is giving you Na2SO4 plus 2H2O. Clear? Okay. Now let us do the next question. Okay, so in this next question, what are the elements? Let us note down. We have first sodium, okay, next we have chlorine, then you can find Ag, okay, then you can find nitrogen, okay, then you can find oxygen, okay, and here I will write reactants and products, okay, fine. So sodium you can find 1 on this side, reactant side, product side also 1, okay, chlorine 1 on the reactant side, 1 on the product side, okay, fine. Silver 1 here, 1 here, okay, nitrogen 1 here, 1 here, okay, oxygen 3 here and 3 here. So I think this reaction is already balanced, right? We need not balance it, it is already balanced, already balanced. Okay, now let us do the next question here, okay. So I'll change the elements name here, okay, 1 second. Okay, so we have elements first here barium, okay, next we have chlorine, then I have hydrogen, sulfur and oxygen, okay. So now if I just write the number of atoms on both sides, so what will I observe? So barium here 1, here 1, right? So I can write 1 and 1. Chlorine here I have 2, there I have 1, okay. Hydrogen here 2, here 1. Sulfur I have 1 here and 1 here. Oxygen here 4 and here also 4, okay. So chlorine, if you see, we have 2 chlorines, right? So I'll make this one as 2HCl. I think now the problem is solved. Barium 1 1, okay. Next chlorine 2, now here also chlorine has become 2, okay, here also the chlorine has become 2. Next hydrogen 2 2, so that also became 2 2. Sulfur I have 1 and 1, oxygen I have 4 and 4, okay. So yes, this reaction we can balance with multiplying 2HCl, okay. So students, see, now you are in 10th. After you complete your 10th, many students get confused like what career they need to choose, okay. They do not have any proper guidance, they just get deviated, or sometimes they just follow the rush, okay, all my friends are doing this, I'll also do, right? You get so much confused at this point of time. So to help you with this, we have come up with a solution that is called as DSAT. So this is Diksha Scholastic Aptitude Test. So what will happen in this? So you can see here in this you will be given a 60-minute, okay, 60-minute concept based lecture, okay. So first there will be a 60-minute concept based lecture, and then you need to write an aptitude test on that particular lecture that you have attended. So then your test will be verified, and then you will be having a one-on-one counseling, and the mentor will definitely check your strength and weakness and will suggest you which career will be best for you, okay. So that is there in DSAT. It is very, very helpful, students. So if you want to register for DSAT, the link is there in the description section, so please go there, register it, and definitely this will help you to make your career more, you have a guidance to choose your career here, okay. So now let's get back to our class, that is what we were discussing, that is types of reaction. So we have understood what is chemical reaction, what is chemical equation, okay, how to balance a chemical equation. Now something is called as types of reaction. The first type is combination reaction, very simple, when 2 atoms or 2 elements combines to give you only a single product, that is called as combination reaction, okay. So the definition you can see, a reaction in which a single product is formed from 2 or more reactants is known as a combination reaction. Now let us see the examples here. You can see carbon plus oxygen giving you carbon dioxide, H2 plus O2 giving you water, CH4 plus 2O2 gives you carbon dioxide plus water, okay. So now what happens, see here, whenever anything reacts with oxygen, okay, these type of reactions are called as combustion reactions, okay. Whenever anything reacts with oxygen, it is called as combustion reaction, And in case of combustion reaction, apart from the product, there is something else is also produced, and that is energy. Okay, energy in the form of heat. Okay, here also we will get energy. Okay, so these type of reactions in which the heat is released, okay, you can see heat is produced as a byproduct. Heat is released along with the formation of products is called as exothermic chemical reaction. Okay, so now you understood what is combination reaction. In this, two types of reactants will react to give you one single product. Now, if anything is reacting with oxygen, then we call it combustion reaction. And in combustion reaction, along with product, some amount of heat energy is produced. So generally, in whichever reactions we have heat is produced in the reaction, those type of reactions are called as exothermic reactions. Now here there is also an opposite reaction, which is endothermic reactions. Now in endothermic reactions, what happens? Heat is not produced, rather we can say that endothermic are those reactions where heat is required. Okay, if you give heat, then only the reaction will take place. So that is what is endothermic reactions. We will see many examples of endothermic reactions as well. Okay, next there is a very common process that we undergo every day, that is respiration, right? And you should remember that respiration is also an exothermic reactions. Now why respiration is an exothermic reaction? See, whatever food you eat, okay, that has some complex carbohydrates, right? These complex carbohydrates are first broken down to simpler substances called as glucose. Okay, now when you breathe in oxygen, the glucose present in your body reacts with this oxygen to give you carbon dioxide, water, and a lot amount of energy, right? So because energy is released here, again this is an example of exothermic reaction. Next, if you see decomposition of vegetable matter into compost, this is also an example of exothermic reaction. Okay, let us see the now second type of reaction, that is decomposition reaction. So now this decomposition reaction is completely opposite to combination reaction. In decomposition reaction, what happens? A single reactant breaks down to give you many simpler products. Okay, let us see some example of decomposition reactions here. So the first example, if you see FeSO4, okay, if you give heat here, okay, it will be broken to Fe2O3, SO2 and SO3. So you can see one compound can give you many simpler compounds. Similarly, if you see calcium carbonate, it will, if you provide heat, it will break to calcium oxide and carbon dioxide. So here I will tell you, this calcium carbonate, you should remember, is called as limestone. Okay, the common name is limestone. Okay, and calcium oxide is called as quicklime. Okay. Yeah. Next, now here, this what happens when you provide heat, this gives you simpler compounds, right? So these type of reactions which break down on giving heat are your endothermic reactions. Definitely these are your endothermic reactions. Okay, now apart from this, because you are providing heat and breaking them, so this is also called as thermal decomposition reaction. Okay, next, if you see, AgCl can break to Ag and Cl2. Similarly, AgBr can break to Ag and Br2. Okay, this is also decomposition reaction, but this breaking will not take place if you give heat. Okay, so to break this, you need to give light. Okay, you need to give light here. Okay, and this type of decomposition where we need light to break the molecule is called as photochemical decomposition. Okay, clear? Fine. So now we'll go to the third type of reaction, that is displacement reaction. So you can see this example here, you have AX and B, okay, reactant, and in the product what happens, this B is exchanging this A. Okay, so B is taking the place of A and A is taking the place of B. So we get here BX and A. Okay, so that is a type of displacement reaction. So here you can see certain examples of displacement reaction. Fe plus copper sulfate, you can see Fe will displace copper and you get Fe sulfate and copper. Similarly, if you see zinc and copper sulfate, right, so zinc will replace copper and will get zinc sulfate and copper. Similarly, if you see lead and copper chloride, lead will replace copper and will get lead chloride and copper. right? So these are the different examples of displacement reaction. Now the next reaction is double displacement reaction. So in double displacement reaction, you can see here, suppose AB and CD is reacting, right? So C will come here and A will come here, okay? So we are getting AD and CB, two displacements takes place, okay? One comes here and another goes there. Just an example here, you can see Na2SO4 and barium chloride. So what happens? Barium comes here and sodium comes here. So if barium comes here, we'll get barium sulfate, and sodium comes here, we'll get sodium chloride, okay? This is an example of double displacement reaction, okay? Next, here you should remember, see, barium sulfate is solid, okay? This is insoluble, okay? Some insoluble compound, when a product of the reaction is insoluble, that is called as precipitate. Okay? Now we'll go to the next kind of reaction, that is oxidation and reduction, okay? So, sorry, this is not required here. So oxidation, what is the definition? See, oxidation means addition of oxygen or removal of hydrogen, okay? This is the definition of oxidation. Similarly, if you want to check the definition of reduction, okay? So what is reduction? Reduction is addition of hydrogen and removal of oxygen, okay? Now we'll understand this with example. Now see, copper is, you are adding oxygen to this one, right? So what is happening here? Oxidation, right? This is oxidation. Now copper oxide plus hydrogen, so you see oxygen is removed, right? Oxygen is removed from copper, so that is what? This is reduction reaction. Now if you see zinc oxide and carbon, so from zinc oxide oxygen has been removed, so this is also reduction. Let us see this example now. So if you see in this one, MnO2 HCl MnCl2, right? MnO2 to MnCl2, what has happened? Oxygen has been removed, right? So removal of oxygen means this is what? This is reduction, okay? Now if you see chlorine here, from chlorine HCl to Cl2, what has happened? From HCl, hydrogen has been removed. That means HCl has undergone oxidation, right? So in the reactions where oxidation and reduction takes place simultaneously, okay? Here you see separate reactions has taken place, okay? So where there is simultaneously oxidation and reduction, this is called redox reaction. This example of also, if you see ZnO to Zn, okay? Zinc, oxygen is removed, but if you see carbon to carbon monoxide, oxygen is added. So I can say here that ZnO has undergone what? Reduction, and C has undergone oxidation, right? So these type of reactions where there is both reduction and oxidation are called as redox reactions. Clear? So this is oxidation, reduction and redox reaction examples, okay? So this is redox reactions, okay? Next, let us see the effects of oxidation and reduction. So the first effect is corrosion, okay? So what is corrosion? When a metal is attacked by substances around it, such as moisture and acid, okay, it is said to corrode, and this process is called as corrosion. So whenever metal reacts with moisture, air, okay, and it gets its property, its utility is finished, or utility is declined, then we call it as a process of corrosion. So here are some examples. The black coating on silver, okay, this is also corrosion. Green coating on copper, so when copper reacts with oxygen, atmospheric moisture and oxygen, it gets a green coating over it. Similarly, when silver reacts with atmospheric oxygen or moisture, it gets a black coating on it. And next, if you see iron articles, rusting of iron is very common. I hope all of you have seen it. And the next is rancidity. So what is rancidity? When the fats and oils are oxidized, okay, they get a foul smell, and that is called as rancidity, okay? Foul smell and a change in the taste, okay? So how can we prevent that? We can prevent that by using antioxidants, okay? Different antioxidants can be used. Second thing, we can keep food in the airtight container so that it doesn't come in the contact with oxygen or moisture. Next, you know, chips packet, okay, you have seen they are like very fluffy, very balloon type, they are filled with gases, right? So which gases is used here? The nitrogen gas is used here, okay? Nitrogen provides an inert atmosphere, so the chips cannot come in contact with the air, and that is why they do not undergo oxidation, and they are prevented from rancidity. Okay, so so once again I want to remind you about DSAT. So as I told you, after 10th it is a very critical situation where you need to decide about your career. So if you are confused, please do not worry, we have the solution, that is DSAT, Diksha Scholastic Aptitude Test. So what you have to do in this, you get a 60-minute lecture, okay, and based on this lecture there will be an aptitude test, and then it will be evaluated, and based on your strength and weakness you will be having a one-on-one session with a mentor who can guide you which career will be suitable for you. Okay, you do not have to follow the rush, you do not have to follow crowd, you do not have to listen anyone. You can just talk to the mentor, they will analyze, evaluate you properly and can give the best decision for you. Okay, so if you want to go for DSAT, please register. The link of the registration is there in the description section. Okay, so yes students, we are done with the first chapter, that is your chemical reactions and equations. So I hope this video was helpful, you would have revised all the concept. Please stay tuned tomorrow at the same time 6 p.m. where we will be solving very important questions that are definitely can be asked in your board examinations. Okay, so please stay tuned, and if you are liking this video, do not forget to subscribe the channel. One more thing, if you want this PDF and all, the link will be available, the PDFs are available in our WhatsApp channel, and the link is available in the description section of this video. Okay, so thank you for watching, and once again all the very best for your 10th board examinations.